Hello everyone, and welcome to the 5th installment of the DunaMax mission in the space program Planting Flags. We can see here in the tracking station, the DunaMax vessel is orbiting Kerbin. It's a very pretty circular orbit with a 214 kilometer apoapsis and a 200 kilometer periapsis. In other words, perfect conditions for a launch to Duna. Duna is what Mars would be in the real world. And as you may know, NASA and humanity would much like to go to Mars, although not as much as I personally would like it. Anyway, this is our vessel. Perhaps you remember it from last time. Why is it completely black? Either a texture has not loaded or it's just this dark here in space. Here's the sun. Let's have a look at that. I think something is up. Anyway, maybe this will resolve itself later. We will see. Anyway. So, to go to Duna, here is Kerbin. This is the Earth for all intents and purposes. Zooming out, we find its orbit around the Sun, Kerbal here. It orbits in this direction, and the red planet is Duna. Now, what we are going to do to transfer there is to increase our orbit. For all intents and purposes, our orbit is now Kerbin's orbit. We are in orbit of it, but on the grand scale of things, that doesn't really matter. So we are going to burn here. This means the other side of the orbit will increase. It will rise and rise and rise up until it reaches here Duna's orbit. This would be an intercept. Obviously, Kerbin is rotating around the Sun, as is Duna. So we need to wait until the right moment that the transfer time from this ellipse to this one will correspond to the time that Duna will have to the time that Duna takes to get there. In other words, get an intercept. Using fancy maths, we calculate that the angle, if we put here Kerbin on this axis, the angle here needs to be 44 degrees. So it has to, from here, this is a botched up explanation. We need to wait until Kerbin is 44 degrees in a circle behind Duna. Right now it's about 100, I'm eyeballing this. And I don't calculate this, I use the website ksp.olax.biz for it. It's a nice handy tool and it gives you these calculations. For now though, we can suffice with stating that it's not quite right yet, so we're going to time warp quite a long time. Oh, we cannot time warp faster than 100 times while below 240 kilometers. Well, at 100 times it will take a while. So we're going to do a little trick and see if there is a vessel on the surface that we can switch to. Altitude, or yeah, we're going to switch to this vessel, load this up, and because this one here is in a high orbit around Minmus, the time warp is allowed to go higher. Here we have it. No, we didn't even switch. What happens? Jesus Christ. Going back to the Space Center. That would be a nice feature, by the way, to have time warp from the Space Center. As of now, we don't have this. So let's have a look. We go to the Minmus ship and see if we are allowed to time warp there. Now, since the universe is persistent, if we time warp here, the other ship time warps as well, of course. This makes the restriction of time warping at a certain altitude a little bit silly for these purposes, but if you actually had it for a planet, it makes sense, because otherwise you crash into it or even clip through it before you can do anything. So, attention, back to the mission. We are time warping time forward at 100,000 times now, which is rather fast. This is well, we're at 10 days in already, so this is going really fast, and we're at 90-degree angle now. Remember, this is the angle between Kerbin and Duna. It needs to go to 44. Now I'm just going to eyeball this, so I'm rotating the screen to keep Kerbin on the right side, and I want them at, I'm going to guess for a 45-degree angle. I mean, it's not the actual angle I want to hit is 44.36, which is far too precise to eyeball. So I think a little bit more, and that should do it. We're about halfway there, reducing time warp to 10,000 times regular time. And a little bit more, 10,000 is just too slow. And I think this here is about perfect. So, we'll see how well that goes. Quick saving the game to preserve the time state, and then switching back to the DunaMax, of course. Let's have a look. Here. Now, it's important that we leave Kerbin in a proper fashion. We want to leave the planet going in the prograde direction. We want to expand our orbit. It has to go that way. If we leave the other way, it's going to shrink the orbit and we're going to head towards the sun. This is not something we want to do. Now to expand the orbit, so we have to leave the planet in this direction, going up on the screen here. Now we're going around the planet counterclockwise. So what we're going to do is we're going to do a burn here. We make this hypothetical maneuver node. Increase it, increase it, increase it. And if we zoom out now, we can see that our orbit is increasing almost to Duna. We still have to set Duna as a target, but as you can see, the ejection is a little bit off. We want it to be along this purple line really, so we're going to move the node along that we can see this projected ejection path to be almost prograde. This is generally close enough, and now we see we even have a little bit of extra altitude, so we're going to reduce that a little bit more. The grey indicators telling us our closest approach, and that they are so close to the planet tells me I did a rather good job with the eyeballing. That's all perfectly fine. So this planned burn is all well and good, but if we look at it, we need to do a 972 meters per second ejection burn, which is a rather sizable burn for a nuclear engine powered rocket. This will need a long time to do this burn, so we are probably going to do it in more than one go. At first though, moving in a quick save just so we can resume from this point if something horrible goes wrong or if we have a crash. I'm aligning the rocket here on the nav ball to the prograde marker, and then I'm going to fast forward time until we are, and I'm concerned by this lack of textures on the rocket. I'm pretty sure it is a lack of textures, not just light. We will see what happens when we light the engines. If I do the landing gear, let's see, reduce time warp is the landing gear. The landing gear just works. It's a shadow rocket. Fine, it's now a shadow rocket. That's perfectly fine with me. Oh no, 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 no. If there is animation like these legs, you shouldn't do time warp while doing the legs, because now they're all weirded out. Maybe I can control them individually. Raise. Yes. Well, that sorted itself out pretty well. So basically what we did here is we launched a big nuclear rocket into orbit using a big heavy lifter. And now all we have to do is use some fancy orbital maneuvering to get from Kerbin orbit here to Duna orbit, and then obviously land there. So let's see how this interplanetary injection burn goes. 10 more minutes until the burning node. I'm going to burn 3 minutes before, because this will, as I said, will be a lengthy burn. So I'm going to burn at, yeah, 3 minutes sounds good, and then as soon as the engines are on, the system will tell me how long the burn would take. So, well, look at that, the burn will take 5 minutes on these engines. And we are now burning 2.5. I'm going to just slightly go to reduce the throttle, so we have half the burn before the node and half the burn after it, as to get maximum precision. Now the first goal here is to increase the speed so much that we reach Kerbin escape velocity. Then we are our own independent entity orbiting the sun. Then halfway through our trajectory we will do a fine-tune, a correction burn to accurately intercept Duna. That's the plan anyway. First order of business is to steer the ship so we remain on course. So remaining on course is very important. Now in the game, a properly executed transfer to Duna takes about 30 days. 30 to 40 days. In real life, a transfer like this would take 9 months. Now you might be wondering, why does it take so long? Obviously there is a long distance involved, but if you drive in your car there might be a long distance involved, and you kind of have control yourself by how fast you go, as to how long traveling such a distance would take. Of course in space it's also possible to go faster, but the transfers we use here and in real life as well are the minimum energy transfers, because the distances are so huge and our rockets are relatively inefficient, and it's just so difficult to lift fuel into orbit. We really want efficiency over speed. So what we are doing is we are lifting 1/2 of the orbit to the altitude of Duna. This is the minimum you have to do. This means you will be at Duna's altitude on the one end of your orbit, and on Earth's altitude, Kerbin's altitude, on the other end. This is not. This is good for meeting the planet. If you time it just right, you meet the planet Duna, and then you can use its atmosphere to, well, relative to Kerbin, to speed you up. Actually, it's like a soft racket that then hit you and accelerate you, but from the perspective of the spacecraft it will be approaching Duna really quickly, and the atmosphere will slow you down and allow you to land on it. This of course costs little to no fuel, or it can be done with a parachute, and this is far more effective than going to Duna and then using rockets to stay next to it or stay in orbit. This is the advantage of going to a planet with an atmosphere. It is also possible to do a far quicker approach. Basically you just point at Duna and you burn your engines until you're going ridiculously fast, and then when you're there, maybe even in a day, you just turn around and stop. The problem is the amount of fuel this takes with our rocket technology is completely excessive. Even with nuclear rockets that have never even been flown in real life, this would be excessive. Even more ridiculous would be a so-called brachistochrone, I think is the correct pronunciation, brachistochrone trajectory, which is basically firing your engines all the time until you're halfway there, then turning around and slowing down the rest of the way. This is the absolute fastest way you can get anywhere. This has never been done on any mission in real life because it's completely out there in fuel requirements. We cannot do it. If you have an engine that requires no fuel or operates through some kind of magic, this is the best way to do it. You just accelerate until you're at the halfway point and then turn around and slow down. In science fiction this is often used as well because such a profile allows for having a constant 1g acceleration, which allows for a semblance of gravity on board of the ship. So we're about halfway through our burn now. 450 meters per second of delta V remaining, and you can see that the fuel for the nuclear rockets is not even close to being depleted yet. I reckon we will have about half of our tankage remaining for maneuvers around Duna, Ike, and possibly a return trip if it's in the stars for these brave Kerbinauts. So nuclear engines really doing their job properly. To do this with chemical rockets is possible. Duna is very much reachable with chemicals alone, but then the launch vehicle would have to be even larger. Now in real life, many missions to Mars have been done, robotic missions. There's currently the rover Curiosity on the surface, which is about car-sized and powered by a nuclear battery. It's quite an awesome project. But of course the dreams of NASA and people like me, and possibly you, are of course to have a manned mission to Mars. The problem here is that the transfer would take a long time, about 9 months, and then you would have to spend about a year and a half on Mars before going on your transfer back, which would also be about 9 months. There is a way to get there faster using a slingshot around Venus. This would get you there in about 6 months, but you'd only have a 1 or 2 week window to spend on Mars, so it's generally seen as being slightly less desirable. The problem, of course, is to bringing along the life support, the food, the water, and everything you would need on the surface mandates a huge mission. So this would definitely involve multiple launches up from Earth, assembling a big rocket ship in orbit, and then taking that off to Mars. A big project, for sure. I think it'd be very much worthwhile, but it brings along with its own interesting kinds of problems. For example, if you're going to store rocket fuel, if you're going to make it liquid hydrogen and oxygen, for example, the liquid hydrogen will just pass right through the tank walls, because hydrogen is the smallest molecule there is. There is no material tank that can hold it. It can hold it for a while, sure, but not forever. It will always just seep out. This is obviously a problem if you want to store it for many years in space. Additionally, radiation in space there is a lot more of it than there is on Earth, because we on Earth, we are protected by the magnetic field, the atmosphere, of course. There's a lot of mass in between. And in space that's not the case, so a prolonged space trip is a radiation hazard. And interestingly, the Curiosity rover, it had a detector for radiation on board to measure just how bad it would be. We're nearing the end of the burn here. Let's see, 20 meters per second remaining. It's 15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's get the engines and see what the trajectory did for us. So first we are going to remove the maneuver node, and we see here our blue trajectory here is leaving Kerbin's sphere of influence. We are leaving the planet. That worked out, and if we zoom out, we see here we are going to be at Duna's altitude here, and closest approach is going to be 900,000 kilometers, which sounds like a lot. It is quite far indeed, but probably something we can tweak out with the correction burn. So putting in a quick save, and I'm going to just time warp until we are out of Kerbin's sphere of influence, and then we can plot a nice burn to intercept Duna. Look, they're leaving the planet behind, and they are definitely on their way. Notice the size of the sun here, the apparent size. It is going to be appear a slight amount smaller when we reach Duna, because we are of course higher up from it. So I think we are out of Kerbin's sphere of influence. No, are we? Yes, we are. We have our own orbit now. So what we do again, we make the maneuver node. The planned move. This move is scheduled 1 day from now. So we're going to slightly increase our speed, make these markers flow together. Let's see. Just by increasing the speed, I don't think we are going to. Yeah, eventually we'll get there by going right quick, but we can't go this quick. So we have to do something else. We have to tweak our trajectory somehow to get to Duna. So we're just going to see what reducing our speed does here. If we reduce it slightly, we're just not going to meet it at all. So we're going to increase the speed. Put these markers together. Now we're at 300 kilometers separation. I see Duna is slightly inclined. So we're going to... I'm not even going to pretend I know what I'm doing. I'm just going to fiddle with these buttons until this closest approach is going to be closer. This is way further. I hope we'll be able to manage it. Why wouldn't we be able to manage it? This way then. Go on. Go on. Give me a. Oh yeah, there we were. There it was. There it was. An intercept. A 14,000 kilometer intercept. Still not great, but at least we're intercepting the planet. To do this, we need... Wow, it's quite a sizable burn. I must have been a little bit off on the injection burn. No matter though. Look there, in the distance is Kerbin. And you can see now the speed has increased, the apparent speed, to 10,000 meters per second, 10 kilometers per second. This is our speed now relative to Kerbal, the sun. Kerbin itself, the planet, orbits the sun at around 9 kilometers per second, and we are going faster, since we just did our huge rocket burn, so our speed is about 10 kilometers per second now. To do this 315 meters per second correction burn, I'm going to do the same thing as before. Find the marker, the indicated marker on the nav ball, time warp to the node, which is in a day, and then do the burn. And eventually, hopefully, we will get to Duna, so we can put a little flag on it and its moon. Now I'm having trouble finding the marker. It is in a weird direction. It definitely is in a weird direction. Now I could probably do this correction burn at a more efficient place, but I'm going to do it here because I found it and I don't want to jiggle around with it more. So, found it, and now time warping forward 1 day. I think I will be doing this at 10,000 times speed. Yes, an hour is about a second now. So 14, 10 hours, 9, 8, 7, 6. 1 hour remaining. 30 minutes. Interestingly, because these are now interplanetary distances, it really doesn't matter if you're 1 minute over or under. We're not in orbit of a planet. Our angle is not drastically changing every minute, really. We are in a very steady trajectory. So the accuracy here is more on the scale of hours than it is on the scale of seconds. This is of course because we still only want to hit the planet. We don't really care where. The NASA team, they did a very, very precise interplanetary transfer. They landed within a window of 12 miles, or about 20 miles, a landing ellipse. This was hugely impressive. They did do it on millisecond accuracy. I'm going to do it with hour accuracy. Also, the Kerbin system is quite a lot smaller than the actual world, about 10 times smaller. So they are rather more impressive than I am, but I think we knew this already. So again, a rocket burn, and if all goes well, we will be put on a trajectory for Duna. And after this burn, I'm going to pop one of these Kerbals outside, make a little spacewalk around the ship, and see if we can light up the textures, because I'm quite sick of riding the shadow dark doom ship. If I can't get the textures, I'll end the video and start the next one to see if it goes any better then and there. In any case, the interplanetary transfer appears to be going well, and I hope you learned how to use the maneuver node system. There is a problem with making the videos here because it's super hot in the room. I'm dripping, literally dripping with sweat. I think it's about 40 or 50 degrees centigrade. This is how dedicated I am to getting to Mars, to getting to Duna. Actually, I think the real astronauts have it a little bit tougher, so I shouldn't complain. But then again, this is internet spaceships. Here we go, 20 more meters per second to scrub off, and getting the engines. Boom. I'm going to remove our marker, cluttering up the screen, and here we are. We have our encounter now, and the periapsis is at 15,000 kilometers, which is far too low. We need this at about 20 kilometers, so we can aero brake, so we can use Duna's atmosphere to slow us down into an orbit, or actually in this picture relative to the sun, speed us up. It will be like we'll be passing along and we'll be hit by a ball of gas and rock traveling faster than us, and that will speed us up. But from our perspective, it speeds us up, getting us in the same orbit as that ball. But from our perspective, we'll be falling toward the planet and we will have to slow down in the atmosphere. Right, so that burn accomplished. Franklin is going to go on an EVA mission. Here we have him. He has his textures. We're going to pop on his lights, and they are not illuminating the spaceship at all. So there's definitely a problem with the textures. He's going to go inside. I'm going to end this video here. The next one will be along shortly. Hopefully with some ship textures. So see you guys in a bit.